Welcome back. So we are taking here the important questions from each chapter. Yes. So this is our eighth session today of Sankalp Yashas. So I welcome you all here. So today, so in the last class, we have started with electrochemistry chapter. Yes. So we know now what is electrochemistry. Yes. So what do you mean by electrochemistry? Electrochemistry is what? It is a branch of chemistry which deals with the interconversion of chemical energy into electrical energy, right? So what are the total number of marks which are allotted for electrochemistry? We have seen it is 14 marks. Yes. So in 14 marks, you have 1 marks, 2 questions are asked, and 3 marks, 4 questions are asked. Okay, so out of those 4 questions, 2 questions are theory-based questions and 2 questions are numerical questions. So these 3 marks theory-based questions, it won't be direct questions. Okay, so again, it will be divided into 2 plus 1. Fine. So last class we were discussing about what are conductors. We have seen what are insulators, right? Then we have seen what are metallic conductors, what are electrolytic conductors, right? So how the conductivity in metallic conductors. So the conductivity in metallic conductors, it is due to the electrons. Okay, it is due to the electrons. And in terms of electrolytic conductance, the conductivity is what? It is due to the ions, okay, due to the mobility of ions. So this conductors part we have seen in the last class. So today we are going to start with the conductance of electrolytic solution, which is a very important. Okay, so conductivity, how does your conductivity affects? Yes, with respect to electrolytic solution. So when you increase the conductivity, yes, what will happen to conductivity of electrolytic solutions? So it decreases with increase in dilution. Okay, so when you do the dilution, okay, when you add water, okay, when you add water to, so how do you dilute the solution? So if the concentrated solutions, okay, if you have a concentrated solution, to the same concentrated solution, when you add water, what will happen? The solution gets diluted. Okay, so what will happen? So when in terms of electrolytic solution, that is conductivity, okay, that is specific conductivity when we are talking about, it decreases with increase in dilution. Okay, what happens to conductivity? It decreases when you increase the dilution. As you keep on adding the water, what will happen to the concentration of the electrolytic solution? It goes on decreasing. Okay, so as you increase the dilution, there will be decrease in the conductivity. Okay, so the SI unit of conductivity is given as Siemens per meter. Please remember the SI unit, very important. Siemens, S capital S represents as Siemens per meter. Okay, then molar conductivity. What do you mean by molar conductivity? So molar conductivity, what happens to molar conductivity? It increases with increase in dilution. Okay. So molar conductivity, what happens to molar conductivity? So as you add the water for a concentrated solution, what will happen? So as you increase the dilution, the molar conductivity also goes on increases. Okay. So the SI unit for molar conductivity is given as Siemens meter square per mole. So remember these units. So conductivity. Okay. So these two conductivity, specific conductivity and your molar conductivity are two different terms. Okay. So specific conductivity, it is nothing but it is the inverse of resistivity. Remember that specific conductivity, it is a reverse of reverse of resistivity. And molar conductivity, what it means? So it is due to the ions. Okay, the conductions, it is due to all the ions which are produced from 1 mole of electrolyte. Okay, in a solution, it is given as your molar conductivity. So we have seen the units of molar conductivity. It is Siemens per meter per mole. Okay, Siemens per meter per mole. Yes. Okay, so this is about the conductance. So this is about the conductance of electrolytic solution. So remember about specific conductivity and molar conductivity. So this is asked question. Okay. So next important concept is about type of cells. Okay. So next is about type of cells. So there are two types of cells. Okay, so first is the electrolytic cell and second is the electrochemical cell. Now, what do you mean by electrochemical cell? So first we'll see what do you mean by electrochemical cell. So it is a device in which electricity is produced using spontaneous redox reaction. Okay. So what happens? Your redox reaction is nothing but it is a chemical reaction. What do you mean by redox reaction? So redox reactions are those reactions where simultaneously oxidation and reduction takes place. Okay, so electrochemical cells. Okay, so it is a device in which electricity is produced using a spontaneous redox reaction. It is called as what? Electrochemical cell. So so your electrochemical cells, the best example is Daniell cell. Remember this, okay? For electrochemical cell, which is the best example, it is the Daniell cell. Okay. Uh, so your construction and working of Daniell cell is asked. So we will be seeing it later. Okay. So construction and working of Daniell cell. Okay. So that we are going to see. Then the next is electrolytic cell. Next is what? Electrolytic cell. So your cell representation and all is very important. Okay. So what is electrolytic cell? Yes, can anyone tell me what is electrolytic cell? What do you mean by electrolytic cell? What is done in electrolytic cell? What is electrolysis? What is electrolysis? We are supplying electricity, right? So, what is happening? Electrolysis is nothing but it is a process of decomposition. Okay, it is a process of decomposition of an electrolyte when you are applying an electric current. Okay, so when you are applying an electric current, yes. So what is done here in electrolysis? What is that? Electric energy is converted into your chemical energy. Okay, in electrochemical cell, what is happening? Chemical energy is converted into electrical energy. Okay, so here electrolytic cell. Okay, what is electrolytic cell? So electrolytic cell, what is happening here? The electrical energy is converted into your chemical energy. Okay, so next is cells. Yes, next is cells. What do you mean by cell? What do you mean by a cell? What do you mean by a cell? Yes, cell or you can call it as a battery. Okay, so you know that battery. What is a battery? So you have seen different types of batteries, right? So what is a battery? It is nothing but arrangement of one or more electrochemical cells. So when these electrochemical cells they are arranged, okay, when they are arranged in a series. So when they are arranged in a series, okay, so that is nothing but your battery. So battery is what? It is a arrangement of one or more electrochemical cells, okay, and they are connected in a series, okay. So what is the role of this battery or a cell? It converts the chemical energy into electrical energy, okay, by the redox reaction. So what is happening? Simultaneously oxidation and reduction takes place. So what is happening here? So the chemical energy is converted into electrical energy. Okay, what is done? The chemical energy is converted into the electrical energy. Okay, so this is the role of the battery. So battery, what is a battery? So what is a battery? So battery or a cell It converts, what is the role? It converts the chemical energy into the electrical energy by a redox reaction. So there are two types of batteries which you are going to study. Okay. So which are the two types of battery? One is the primary cells. Okay. Primary battery or primary cells, and the second one is secondary cells. So what is the simplest definition of primary cells? Primary cells, they cannot be recharged or reused. So where you can see, you can use them in the toys, okay, electrical toys which you use for playing, and also the cars and all, right? Your for the TV remotes, so wherein you use the batteries. So those batteries, okay, so these cannot be recharged and you cannot reuse them. Okay, so once the battery get discharged, you have to throw them. Okay, so primary cells are those cells which cannot be recharged and they cannot be reused. You have to throw them once it is discharged. Once the cells get discharged, you have to throw them. It cannot be reused. Okay, so the example is dry cell. So dry cell, so the anode, remember this. Okay, remember this. Anode is made up of zinc, cathode is made up of MnO2 plus carbon. Okay, MnO2 plus carbon. Then electrolyte is your paste of ammonium chloride plus zinc chloride. The paste electrolyte which is used, okay, so it is a paste of ammonium chloride plus zinc chloride. Then the second example of primary cell is mercury cell. Okay, so anode is made up of zinc amalgam and cathode is made up of zinc oxide plus carbon. Okay, HgO. Okay, that is mercurous oxide plus your carbon, and electrolyte uses potassium hydroxide plus zinc oxide. So remember this cathode, anode, and the electrolyte which is used in mercury cell and in the dry cell. Please note it down. Okay, I have told you. I'm been telling you from the first class. Please take a paper and a pen and please note down these important things. Okay, so now you will be remembering all the things, but as the time passes, this will vanish out. Okay, so please note down this thing. So a dry cell, which is the anode, which is a cathode, okay, and what is electrolyte? Then in mercury cell, okay, which is anode, cathode, and electrolyte. And what are these dry cell and mercury cell? These are the example of primary cell. What are primary cell? Okay, in short notes you have to write. Then next is secondary cells. What are secondary cells? So secondary cells, they can be recharged and they can be reused. So once the battery gets discharged, okay, once the battery gets discharged, what you can do? You can charge them. You can charge them and you can again reuse them. So these batteries can be reused. Okay. So what is the example? Lead storage battery. Okay, the example is lead storage battery. Then what is the anode use here is lead. Okay, cathode is lead plus lead oxide. Then electrolyte uses 38% sulfuric acid. Please note it down. So lead in lead storage battery, which is the anode, cathode, and the electrolyte. Then the second example of the secondary cells is what? It is a nickel cadmium cell. What is it? Nickel cadmium cells. Okay. Next important things is fuel cell. Okay, it is about fuel cell. So what are these fuel cells now? So fuel cells, they are the galvanic cells. Okay, so these are called as galvanic cells. Okay, which is used to convert the combustion energy of fuels like hydrogen, methane into electrical energy. So combustion energy. Okay, so combustion energy of the fuels like the your hydrogen, methane, methanol, they can be directly converted into electrical energy. So the best example is H2O2 fuel cell. Okay, that is hydrogen oxygen fuel cell. So this is the example of a fuel cell. So what are fuel cells? These are the galvanic cells, okay, which are used to convert the combustion energy of the fuels like your hydrogen, methane, methanol into your electrical energy. Okay, so the best example of a fuel cell is hydrogen oxygen fuel cell. Okay, remember this. So these are the equations, Nernst equation for Daniel cell. Please note this equations. Okay, so based on this, we are going to solve the questions at the end. So Nernst equation for Daniell cell, it is given by E cell is equals to E naught of cell is minus 0.059 divided by 2 log of Zn plus 2 divided by copper plus 2. Okay. So, this is in bracket. Why they write in the bracket? This represents your molar concentrations. Okay. Then the next is relationship between equilibrium constant and E naught of cell. How it is given? E naught of cell is equals to 0.059 divided by 9. Okay, so relationship between equilibrium constant and E naught of cell is given by E naught of cell is equals to 0.059 divided by n log to the base 10 k of c. Okay. Uh, then relation between delta G naught and E naught of cell is equals to delta G naught is equals to minus n f E naught cell. So based on this, we are going to solve the questions. So these were some of the basic things. Okay. So now we are going to start with the MCQs. So from this chapter, 2 MCQs are asked. Okay, no fill in the blanks from this chapter. So you'll be getting the MCQs on this particular chapter. So the first question is, how much of electricity in terms of Faraday is required for the oxidation of H2O2 to give you O2? Okay, so how much Faraday is required for the oxidation of H2O to give you oxygen, O2? Yes, A 1 Faraday, B 0.1 Faraday, C 2 Faraday, and D 0.2 Faraday. Yes. How much of electricity in terms of Faraday is required for the oxidation? Okay, Nikita has answered it as A. What about others? Okay, Sanjini, Shivkumar, Supriya, all have answered it as A. Simran has answered it as B. Okay, we'll see. Okay, Vinushri has answered it as A. Okay, I'll solve it. Okay. Um, See here. So H2O. So H2O to give you O2. Okay, how much Faraday is required? So there is 1 mole of H2O gives you O2. Okay, for 1 mole of. So what is a chemical reaction? So chemical reaction, so when water molecule, okay, it gives 2H plus when it splits, okay, it gives 2H plus half O2 plus 2 electrons. Okay, so when H2O, it undergoes the chemical reaction, it gives you 2H plus half O2 plus 2 electrons. Okay, so here how many moles of electrons are released? Released when 1 mole of H2O is decomposing to give you O2. Yes, how many moles of electrons are released here? 2 moles, right? So 2 moles of electrons are released when 1 mole of water decomposes to give you O2. Okay, so amount of charge is equal to 2 Faraday. So the amount of charge is what required is 2 Faraday. Okay, so how much moles of electrons is released? 2 electrons. So 2 electrons. So when 2 moles of electrons released when 1 mole of H2O, okay, decomposes to give you O2. Fine. So how much amount of energy is required? It is 2 Faraday. Okay, so option number C. Okay, option number C is the answer. So next question. In the salt bridge, KCl is used because. Why KCl is used? A, KCl is an electrolyte. B, K plus and Cl minus ions have same mobility. C, K plus and Cl minus ions are isoelectronic. And D, agar-agar forms good jelly with KCl. Yes, why in the salt bridge KCl is used? What is the reason? Okay, Supriya has answered it as A. Sorry, B. Shubham has answered it as D. Nikita has answered it as D. Priyanka D. Praveen D. What is the can you tell me what is the role of the salt bridge? Yes, what is the role of the salt bridge? What is the role of the salt bridge? Yes. Can anyone tell me what is the role of the salt bridge? What is the role? So the main function uh, of the salt bridge is to transfer the cations and the anions in the solution. Okay, so what is done? Two different beakers are taken, right? So your electrode and its electrolyte and another electrode and its electrolyte. So how the ions will get transferred? By using the salt bridge. Okay, by using the salt bridge, what is happening? The ions get transferred. So the main function of the your salt bridge is what? The transfer of cations and anions in the solution. Okay, and what it will do? It will maintain the neutrality. Okay, it will maintain the neutrality. Okay, so what is electrolyte? What is the electrolyte? Electrolyte is nothing but it is in electrolytes are inert. Inert in nature means what? They do not react. Okay, they do not react. Okay, so they do not take part in chemical reaction. So chemical reaction means what? It undergoes a redox reaction, right? So here a redox reaction takes place. So one side oxidation takes place, one side reduction takes place. Okay, so electrolytes, they do not participate in the reaction. Okay, so they just participate in the reaction without getting mixed in the solution. Okay, so what is the why it is used? The salt bridge. Yes, just now I have told you what is the main function of the salt bridge to for transferring and to maintain the neutrality. Okay, so that the answer is B. The answer is B. K plus ions and Cl minus ions, they have same mobility. Okay, so K plus ions and Cl minus ions will have same mobility. Understood? Yes. Is it clear? Are you getting me? Please chat in the chat box. You can leave a message there. Is it clear? Shall we move further? Any doubts? Okay. So okay, so we'll move further. So moving further, the next question, the conductivity of electrolytic conductors is due to A, flow of free mobile electrons, B, movement of ions, C, either movement of electrons or ions, and D cannot be said. So the conductivity of electrolytic conductors is due to what? So we have seen this in the concept part. Oh, just the last slide. Yes. So the conductivity of electrolytic conductors is due to because of free mobile electrons, movement of ions, C, movement of electrons or ions, or cannot be said. It is, yes, I've got 4 answers. B, yes, everybody has answered it as B. Good. Vedavati, Simran, Shubham, Shivkumar, Supriya, yes, good. It is B, movement of ions. Okay, so the conductivity of electrolytic conductors is due to movement of ions. Okay, moving further. Next question. In a fuel cell, which of the following can be utilized as a fuel? A, nitrogen, B, argon, C, hydrogen, and D, helium. So in a fuel cell, what are we utilizing as a fuel? So we have seen the best example. Yes, I've got the answer. Praveen, Shivkumar, Shubham, Priyanka, Simran have answered it right. Vedavati, Sita. Yes, it is C, hydrogen. Okay. So in a fuel cell, chemical energy is converted into electrical energy, right? So which are the two gases used? Hydrogen and oxygen, right? So H2 and O2 gases are used in a fuel cell along with the water and heat, right? So hydrogen. So out of these four options, hydrogen is the right answer. Good. So good that you're answering. Okay. So next question. Rust is a. What is rust? A. Hydrated Fe2O3. B. Hydrated Fe3O4. C. Hydrated FeO. And D. Mixture of Fe2O3 and Fe3O4. Yes. What is rust? What is rust? Okay, I've got the answers. A. Priya, Sita, Priyanka, Shushma, Supriya. No, not Supriya. Shushma have answered it as A. Supriya has answered it as C. Okay. So what is rust? What do you mean by rust? When iron, okay, when the iron, okay, suppose you take, for example, your the gate in front of your house, okay. So if you keep it, so it is made up of what? It is made up of iron, right? So iron. So this iron, if it is exposed, okay, if it is exposed to air and moisture, what will happen after some time? This will get rust. What do you mean by rust? Rust is nothing but a oxide layer is formed on this. So on this, so due to when it comes in contact with the moisture, okay, moisture is nothing but your water and oxygen. So when it comes in contact with moisture, air, the oxygen, okay, it forms a reddish brown color, okay, layer. And this is nothing but the rust. And this is due to iron oxide. Okay, so iron oxide is formed. So what is happening? The reaction is between the iron and the oxygen, okay, in the presence of water and air. Fine. So rust, it consists of nothing but iron oxide, that is hydrated Fe2O3. Fine. It is hydrated Fe2O3. Answer is A. Understood? So the answer is A. So rust is nothing but it is a hydrated Fe2O3. So iron, okay, along with this what? Oxygen. When it reacts with oxygen in the presence of water and the air, okay, it forms a oxide layer on the iron, and that is nothing but iron oxide. So it consists of hydrated Fe2O3. Okay, hydrated Fe2O3 is a rust, is nothing but a rust. I hope these 5 questions are clear. So we'll move further. Next question. Fused NaCl on electrolysis gives dash on cathode. So fused NaCl on electrolysis gives dash on cathode. A, chlorine, B, sodium, C, sodium amalgam, and D, hydrogen. Yes, what does fused NaCl gives? Fused NaCl is nothing but molten form of NaCl. Okay, that is your sodium chloride. Fine. So when molten NaCl on electrolysis gives you what on at cathode? Okay, I've got the answers. 32. Sodium. Okay. Some have answered it as A, some have answered it as B. Yes. Fused NaCl on electrolysis gives you A chlorine, B sodium, C sodium amalgam, and D hydrogen. Yes. So I'll tell you the answer. So on electrolysis of this molten or your fused NaCl, so as you know, NaCl, okay, when it dissociates into Na plus ions and Cl minus ions, right? So in molten state, okay. So at cathode, what will, so cathode, at cathode, as it is a, cathode means it is a negative terminal. Okay, cathode means it is a negative terminal. So what will happen here? Reduction takes place. What happens here? Reduction takes place. Okay, and at anode, it is a positive terminal. And what happens there? Oxidation takes place. Okay, what do you mean by oxidation and what do you mean by reduction? Yes, what do you mean by oxidation? What do you mean by reduction? Oxidation is nothing but loss of electrons. Okay, oxidation is loss of electrons, reduction is gain of electrons. Gain of electrons. Oxidation is loss of electrons. Okay, so cathode, it is a negative terminal. Reduction is taking place, so there is a gain of electrons, and at anode, it is a positive terminal. Oxidation takes place. There is a loss of electrons. Okay. So what will happen at cathode? What is happening? Sodium will be deposited at cathode. Okay. So sodium is deposited at cathode. So and at anode, your at anode 2Cl minus gives you Cl2 plus 2 electrons. Okay. And at cathode, what happens? Na plus 2 electrons gives you 2 Na. So what happens at cathode? And sodium. Okay. So sodium. So the answer is what? This answer is Na. The answer is Na. Understood? Yes. So these are the reaction. Okay. So this is the reaction. So Na plus, so gain of electrons, right? 2 electrons to give you 2 Na, and your 2 Cl minus, okay, giving you Cl2 gas plus 2 electrons. So at cathode, what happens? Na, okay, sodium is given out on sodium cathode. Okay. The next question: which of the following is a secondary cell? Okay, which of the following is a secondary cell? Yes, what do you mean by secondary cells? So secondary cells are those cells which can be recharged and they can be reused, right? So, the examples are given as A, Lechanke cell, B, lead storage cell, battery, C, concentration cell, and D, all of this. Yes, which is the secondary cell? Okay, I've got the answers. Just a second. Okay, so most of you have answered it as P. Priyanka, Shushma, Shushti, Nikita, Netravati. Yes, the answer is right. It is B. Okay, lead storage battery. So lead storage battery. is a example of a secondary cell. So we have seen what is secondary cell. So what do you mean by secondary cells? So secondary cells are those cells, okay, wherein you can recharge and you can reuse them. Okay, so here the redox reaction, what it does, it converts your chemical energy into electrical energy, and it can be reversed. Okay, how it can be reversed again? It can be reversed by passing the electric current. Okay, so after the battery get discharged, what you can do? You can again recharge them by passing the current through, okay, through the opposite direction, and it can be used again and again. So lead storage battery and nickel cadmium batteries. Okay, remember this nickel cadmium battery and lead storage battery. These are the examples of your this what these are the examples of your secondary batteries. Okay, these are the examples of your secondary batteries. Next one, the difference between the electrode potential of two electrodes when no current is drawn through the cell is called A. Cell potential, B. Cell electromotive force, C. Potential difference, and D. Cell voltage. Praveen has answered it as B. Supriya has answered it as A. Yes, what about others? Nikita C, Netravati B, Simran has answered it as B, Shushma has answered it as C. Yes. So the difference between the electrode potential of two electrodes when no current is drawn to the cell is called as. Yes. It is called as. It is called as cell EMF. Okay, that is cell electromotive cell. Okay, so what is cell electromotive cell? It is nothing but the difference between the electrode potential of the two electrodes when no current is passed to the cell. Okay, and what is cell potential? What do you mean by cell potential? It is the difference between the two cell. Okay, it is also the difference between the electrode potential of two electrodes, but the when the cell is passing the when you pass the electric current to that. Okay, it is the difference is when you pass the electric current to the circuit. Okay, it is called as the potential difference. Then what is potential? Cell potential and potential difference is same. Okay, cell potential or potential difference is one and the same. So it is nothing but the names are different, but the meaning is same. Cell potential and potential difference. Okay, so it is the difference between the electrode potential of two electrodes when the cell is sending the current through the circuit. Okay, it is called as your potential or your potential difference. What is cell voltage? Yes, what do you mean by cell voltage? Cell voltage is nothing but the charge difference between the two electrodes. Okay, it is the charge difference. Charge difference between the two electrodes. So what is happening in cell voltage? The electrons are pulled from anode to cathode in an electrochemical cell. Okay, so the answer is cell electromotive force. So I have just told you the definitions of all others so that it will be easily understood. Next is, which of the following is the example for inert electrode? Okay, A, gold electrode, B, copper electrode, C, zinc electrode, and D, silver electrode. Yes, what is the example? What is electrode? First of all, what is an inert electrode? Inert electrode are those electrodes which do not take what you say participate in the chemical reaction. Okay, say they do not take part in any chemical reaction in a cell. Inert electrode, they do not participate. There won't be any reaction occurring in the inert electrode. They do not participate in the chemical reaction. Okay. Okay, so there are many answers. Rushti has answered it as A, Simran C, Shivkumar D, Shubham A, Praveen has answered it as B, Netravati A, Supriya A. Yes, and the answer is, what is the answer? Answer is A. Okay, A, gold electrode. The answer is A, gold electrode. So remember what is inert electrode? So inert electrodes are those electrodes which do not take part in any chemical reaction in a cell. Okay, they do not participate or they do not take part in any chemical reaction in a cell. So the example for the inert electrode is platinum. Okay, I'll write the platinum, platinum electrode, then gold electrode. Remember this, make a point of these all electrodes. So which are the other examples of inert electrode? Platinum electrode, gold electrode, then graphite. Graphite is what? Graphite is a allotrope of carbon. Okay, so it is a carbon. Graphite is nothing but carbon electrode, and rhodium. And rhodium. Okay. So these are the examples of inert electrode. Is it clear? Yes. Is it clear till here? Any doubts till here? Any doubts? Next question. How does molar conductivity varies with dilution? Okay, how does molar conductivity varies with dilution? A decreases, B increases, C no change, and D inversely proportional. Okay, Netravati has answered it as B, Praveen D, Simran, Vedavati, Supriya, Shubham has answered it as B. Sushma has also answered it as B. Okay. Yes. Okay. So what happens? Molar conductivity. What happens to molar conductivity? I've told you in the starting concept, it increases with dilution. Okay, molar conductivity, it increases with dilution. When you talk about specific conductivity, what will happen with specific conductivity? It decreases with dilution. Okay, so when solution is diluted, what will happen? The total number of ions will increase. Okay, so as the total number of ions will increase, what will happen? Uh, as the total number of ions will increase due to the increase in the degree of dissociation. So therefore, molar conductivity also increases with dilution. Okay. So this is the reason for why molar conductivity increases with dilution. Fine. Next question. Which of the following in aqueous solution forms a conducting solution? So which of the following in aqueous solution forms a conducting solution? A. Fructose, B. Potassium hydroxide, C. Alcohol, and D. Glucose. Okay, Shivkumar has answered it as B. Priyanka, Shubham, Vedvati has answered it as B. What about others? Simran, Praveen, Veena, Shushti. Yes. Okay. So answer is yes. The answer is B, KOH. Okay. The answer is B, KOH. So you know that what is KOH? Potassium hydroxide. What is potassium hydroxide? It is a ionic solution. Okay. So means what? When you add potassium hydroxide in water. So when you add potassium hydroxide in water, it forms a ionic solution. So ionic solution, they have a capability of to conduct electricity. So they what they can do, they can conduct electricity because they have ions. Okay, that is KOH. When you add in water, okay, they can conduct electricity because they consist of ions. Okay, so what ions they have? K plus ions and OH minus ions. So because of these ions, okay, they can conduct electricity. So K plus ions and OH minus. So this KOH, when you add in water, they will split into K plus ions and OH minus ions. So these are the ions. So because of the ionic what you say capability, because these ionic solutions, they have a capability to conduct electricity. Okay. So B, answer is B. Good. Next question. Standard electrode potential of SHE at 298 Kelvin is A minus 0.76 volts, B 0.10 volts, C 0.34 volts, and D 0.0 volts. Netravati, Nikita, Supriya, Shubham, Priyanka. Yes, the answer is right. It is D. Okay. Answer is D. So 0.0 volts. So the standard electrode potential of SHE, okay, it is given as, it is assumed to be 0.0 volts. Okay, standard hydrogen electrode. The potential of this standard hydrogen potential is given as 0.0 volts. Next one. During the electrolysis of molten sodium chloride, the reaction occurs at anode is, okay, chlorine ions are oxidized, B, chlorine ions are reduced, C, sodium ions are oxidized, and D, sodium ions are reduced. Yes, during the electrolysis of molten sodium chloride, we have seen this. Okay, that time what it was, we have seen this, just a backslide. NaCl. See, they have given that time, it was given as fused NaCl. Now they have given as molten NaCl. Molten NaCl and fused NaCl is the same. That time they had asked the reaction occurs at cathodes. Now they have asked what is the reaction occurring at anode. Yes. Okay, good. So many have answered it right. Netravati, Simran, Shubham. Yes, the answer is right. Okay. It is Vedavati. Yes, the answer is. What is the answer? Chlorine, chloride ions are oxidized, right? At anode, chloride ions is oxidized. Chloride ions. Okay, so we have seen that cathode. So what will happen? NaCl, it aqueous solution. Okay, it splits into Na plus ions and Cl minus ions. So at anode, what is happening at anode? Oxidation takes place. Okay. So it is 2Cl minus gives you Cl2 plus 2 electrons. And at cathode, what is happening? At cathode, reduction is happening. Okay. That is Na plus electron giving you Na. Okay. So this Na plus H2O gives you NaOH plus half H2. So what is happening? Chloride ions will get oxidized. Okay. So option number A. So we have seen this. They had asked that time. Here. Sixth question. Okay. So that time they had asked what? At cathode. So that time sodium it was. So fused NaCl or molten NaCl, it is the same. Next question. The unit of quantity of electricity is. So the unit of quantity of electricity is A ampere, B ohms, C volt, and D coulomb. Yes, the unit of quantity of electricity is A ampere, B ohms, C volt, and D coulomb. Netravati has answered it as D. Wait. Okay. What is the unit of quantity of electricity is? It is, the answer is D, coulomb. Coulombs. Okay, the answer is coulomb. So, what is coulomb? The quantity or the unit of quantity of electricity is called as coulomb. Okay, it is Coulomb. Coulomb. Okay. So a coulomb is nothing but it is a quantity of electricity which passes at any point in a circuit in 1 second when a steady current of 1 ampere is flowing. Okay, what is the 1 coulomb? So a coulomb, it is a quantity of electricity which is passing at any point in a circuit in 1 second when a steady current of 1 ampere is flowing. Okay, so this is 1 coulomb. So the unit of quantity of electricity is given as coulombs. Okay. Next, which one of the following is not a good conductor of electricity? A, sodium, solid NaCl, B, metal copper, and C, fused NaCl, and D, brine solution. Yes, which one of the following is not a good conductor of electricity? Which one of the following is not a good conductor of electricity? Okay, Vedvati, Supriya, Shiv Kumar have answered it right. Simran, yes, it is A. It is A, solid NaCl. Okay, solid NaCl, it is a poor conductor of electricity because since the charged particles are solid, right? NaCl is solid. So solids, they are unable to move. Okay, the ions are unable to move. But once you add them in water, the ions will get dissociated into Na plus and Cl minus ions. But here, the solid NaCl, they are intact. Okay, the solid NaCl, it is intact. So the charged particles, they are not able to move, okay, because they are having a strong electrostatic forces. This NaCl is bound by a strong electrostatic forces. So because of this, they cannot conduct electricity, okay. So it is NaCl. So copper metal can conduct electricity. So it is a good conductor. You know that copper, in the wires, okay. So for to supply the electric current, and also the wires which are made up of, it is made up of copper, right? Because copper is a good conductor of electricity. So better than iron, the copper is a good conductor, okay, and it ensures the flow of electric current. Okay, it can easily pass the electric current, so it is a good conductor. So this is wrong. Then fused NaCl is nothing but your molten NaCl. What do you mean by molten NaCl? So yeah, NaCl will be in the molten state, so this can also conduct, right? So this can also conduct. Then brine solution is nothing but your NaCl solution. Okay, NaCl solution is called as the brine solution. So this is also a electrical conductor. So it can also conduct because of the electrons. Okay, so here the electrons are released. So because of the okay, so molten NaCl is also a fine conductor. Fine. So, which is not a good conductor of electricity is a solid NaCl. So, answer number your 15th question, the answer is solid NaCl. Because what is the reason? NaCl, solid NaCl is a uh, poor conductor of electricity because it is intact. Okay, the charged particles are intact. It is held by a strong electrostatic forces. Okay, so they cannot conduct electric current. Okay, so option number A. Is it correct? Is it understood? So we have solved 15 questions. Is it clear? Any doubts still here? Yes. Any doubts? Yes, others, any doubts? So if you have any doubts, you can ask me. Okay, so the 2 marks questions, these 2 marks questions, so I think we can do it in the next class. Okay, so already it is time up. So these 2 mark question we can take up in the next class. Yes, so any doubts regarding today's session, you can ask me. Fine. Okay, so there are no doubts. I hope the things are clear. Yes. So in the next class, we'll be solving 2 marks questions and some numerical parts. Okay. So these were the things. Okay. So I hope you are understanding the things. So as I've said, please note down the things, and as the classes get over, you just revise them. Okay. It will be a good uh, revision for you also. Okay. So that's it. Okay, so we shall end the session here. So we'll meet in the next class. So thank you. Have a good day.